So what is algebra, and what are we going to be doing about it? A lot of times when you say algebra, people kind of get a little scared. They think it's mostly this kind of stuff. Numbers, variables, things we don't really understand. That's really not what algebra is all about. Let me give you an example. Is this algebra? This looks like a problem here. Let's try 1/4 x plus 11 equals 72. Well, to solve this problem, we do 72 minus 11, and then we get an answer that is 61. We take 61 and multiply it by 4. So that's going to give us a total of 244. So that's my answer. I circle it, and I get an A+. Now, sure, I got the right answer, but I didn't even know what I was doing. I was just following some formula. Let's try this again. So we've got the same problem. This time, we're going to use a balancer to kind of explain what we're doing with that equal sign. Now that equal sign is exactly the same as the fulcrum, the place where the yellow line balances. So I'm just going to put underneath there a little triangle. Now this equal sign is really balanced. So this side of the equation is the same as the other side. We are trying to find what x is. X is a variable and it represents a number. So I'm going to put 1/4 times x right here plus 11 equals 72. Now here I've got my balancer over here. Now what I'd like to do is to figure out what x is. So to do that, if I take away 11 from both sides, so I'm just going to take 11 off of my balance on both sides so it stays balanced, so that equal sign still works out. So let's do the same thing with our equation. We're going to take away 11 from both sides, keeping the equal sign equal by doing it to both sides, and we have 1/4 x equals 61. And we can show that on the balance over here, which is really just saying the same thing if that equal sign is our fulcrum. So now we've got to figure out what x is. We know 1/4 of x equals 61. So if we take 4 times 61, we should be able to figure out what x is. So we're going to multiply both sides of the equation by 4. That way we're not changing it. We're multiplying both sides by 4. And we have x is equal to 244. So if we were to draw that, we would have x on one side and 244 on the other. We have now solved for x and done an algebra problem. But this really isn't why we use algebra either. When have you ever really heard someone say, I just need to know what x is? Here I have this equation, I need to know what x is. So we have to look at algebra through the eyes of the real world. So remember, when life gives you lemons, we're going to make algebra lemonade. I like to relate algebra to food. So say you're running a lemonade stand and you put in $11 of your own money into the cash box so that you can make change. You have a very busy day and plan to sell again tomorrow. You notice you're running low on cups and wonder if you have enough, if business is similar to that of it was today. So since you didn't keep track of how many cups you actually sold, you look at the money left in your box and you count it. So you made a total of $72 and you want to know how many glasses of lemonade did you sell today? Well, you need to know how much each glass of lemonade costs. And so each glass of lemonade, let's say we sold it for 25 cents. Now by looking at the amount that we made and the cost of each glass of lemonade, we can calculate how many glasses we sold, and then we can see if we have enough glasses to sell lemonade again tomorrow. I look over and I see I have a package of 200 cups, and I'm wondering, do I need to go to the store tonight so that I can sell all of my lemonade and make $72 again? Make the same amount of money tomorrow? Now I know what you're thinking when you look at this. You think, oh, big ugly story problem. But really, this is how come we use algebra. It's not to solve for some random variable x. So if you really want to learn algebra, even though you can do the patterns, you have to be able to turn in everyday life into an algebraic problem. Now we did this when we were talking about variables. So let's revisit what a variable is. So I'm going to go ahead and draw my balance with the fulcrum in the middle so it's perfectly balanced. And now I have to figure out what's on each side of my balance. So I'm going to put the total amount in my cash box on this side of the balance. And my goal is to know how many glasses of lemonade did I sell today. So I'm going to use a variable, and I could choose X if I wanted to, but I'm going to go ahead and choose L just for fun. And L is equal to the number of glasses of lemonade I sold today, not the ones tomorrow. It's the number of glasses of lemonade I sold today. So I can use this variable to figure out how much money I made just from selling glasses of lemonade. So if I sold one glass, it would be 0.25 times 1 or 25 cents. 2 glasses, 0.25 times 2 or 50 cents. L glasses, 0.25 times L. And that will give me how much I made just selling lemonade. Now wait a minute though. Remember, originally in my cash drawer, I put $11 so I could make change. I can't just forget about that $11 because in the $72, I know 11 of that is the stuff I already put in. So I can put plus 11 here. Now these two sides have to be equal. However much I made from the lemonade plus the $11 has got to give me $72. So now I can write it as an equation. So 0.25 L plus 11 is equal to 72. And I know what all of those numbers mean. This is more like algebra. Now I'm going to use the same balancing concept, and I'm going to take away 11 from both sides. So I'm removing 11, and then I'll get 0.25 times the number of glasses of lemonade sold today equals $61. Now the cool thing about math is you can actually represent it different ways as long as you're following the mathematical rules. So instead of 0.25 L, we can have 1/4 L. So that's a fourth of $1. 1/4 times the number of glasses of lemonade sold today gives us $61. We can also rewrite it over here. So 0.25 times L equals $61. And we can go ahead and solve each of these equations. They will give us the same answer. So we can do 61 divided by 0.25. And you have to remember here how to do your decimal division. So since it's a 0.25 right here, we're actually going to multiply both of them by 100. So 0.25 times 100 is 25, and 61 times 100 is 6100. So in effect, we're moving the decimal place over twice. And since we did it with both of them, it doesn't change our answer. So 25 into 61, 50. And we're going to go ahead and subtract that and get 11. And bring down the 0 there. So we have 110. And that's 4 times. All right, so we get 244. So the number of glasses of lemonade that we sold today is 244. And we can do the same problem over here, like when we were doing our variables. We can multiply both sides by 4, not changing the balance, and we have the number of glasses of lemonade equal to 244. Now let's change everything. Let's make everything a variable. Let's let M equal the price of each cup of lemonade in dollars, and let's let B equal to the amount of money you put in your cash box before you start selling. So that's another variable that can change. And let X equal the number of cups of lemonade you sell, and we're going to let Y equal to the money left in your cash box at the end of the day. Now by doing this, we can change all of those different variables to represent different situations. Again, really great for our computer programming. Now if we take M, the price of a cup of lemonade in dollars, and we multiply it by the number of cups, we will actually get how much money we made. And if we add the amount we started with in the cash box, our B, that is equal to the ending amount that we're going to come up with in our box. That would be Y. Now we have an equation that gives us a lot of power. We have variables for all of them, and we can represent different situations for all of them. If we take the price, M, times the number of cups, X, and we add what was originally in the box, we're going to get Y. Now we can make this equation look like whatever we want to solve for any of those variables. Let's take a look at how this works. So let's say we want to solve for the amount of cups. Well, we want to get that x variable all by itself. So we're going to subtract a b from both sides. And when we do that, that plus b minus b is going to give us a 0 on that side, and then y minus b on the other side. Now we can't actually do that calculation because we don't have any numbers. We're just going to leave it in variables. Now dividing both sides by m, we've solved for x, our number of cups of lemonade. So x is equal to whatever y is minus b over m, the price of our cups. Now if we know those variables, we can actually plug everything in and find our number of cups no matter what any of those variables are. So remember, m is the price we're selling the cups in dollars, x is the number of cups sold, and b is the cash before you start, what's in your cash box for change, and y is the cash in the box at the end. So that's the total money in your box at the end. So we can figure out our cups sold. We can actually take it, give it to a computer, and the computer can calculate that as long as we have all of the given values for any variables, any of those values. So now let's look if we want to solve for b. Say we want to know the cash before we started. We didn't look at the cash box. So we want to get b by itself, and so we're going to subtract m times x from both sides. So then we get a b is equal to a y minus mx. Now again, it's all solved for b. All we would have to do is plug in those values to figure out the cash we had before we started. So now let's take a look at m. M is our price we're selling the cups for in dollars. Now of course we usually know what we're selling it for. By writing it in terms of variables, it allows us to look at lots of different circumstances that we could have. So solving for m, what we're going to do is we're going to subtract a b from both sides. And that will give us mx is equal to y minus b. Now dividing by x, and we have m is equal to y minus b over x. So now we have the price of selling the cups in dollars written in terms of all other variables. And by doing this, it allows us to look at a general situation without using any specific numbers. And that's what algebra is really about. Now, I have something to confess about math. No one feels good at math all the time. There are always stumpers. It's what we do when we get stumped that really tells us the kind of mathematician we'll be. People aren't born with math brains or without math brains. It's all about what you do, except for maybe some crazy geniuses, like Einstein. Even Einstein went to other mathematicians to get help on problems he didn't understand how to represent mathematically. If you build math muscles with practice and staying with a really hard problem, you will get better. Just like if you're a runner and you run every day, or a professional competitive hot dog eater and you practice gulping down those dogs every day. Don't ever feel like you're not good at math if you can't solve a problem. Some problems just require a little extra flexing. Some problems really do make you sweat, and the harder you work at it, the stronger you'll become. So don't worry, we'll do a little sweating. But I'll try to make it as entertaining and supportive as possible so you can flex your math muscles.